This is Modern Automotive Technology, Chapter 9, Vehicle Maintenance, Fluid Service, and Recycling. Objectives. After studying this chapter, you will be able to explain the importance of vehicle maintenance, check a vehicle's fluid levels, perform an engine oil and filter change, perform an automatic transmission fluid and filter change, locate fluid leaks, inspect a vehicle for general problems with hoses, belts, idler pulleys, and other components. Demonstrate safe practices while working with vehicle fluids and lubricants. Recycle or properly dispose of auto shop wastes. Correctly answer ASE certification test questions on fluid service and vehicle maintenance. Technical terms: chassis lubrication, dry stick or wax lubricant, engine oil, fluid capacity, graphite, grease gun, grease job, oil foaming, service interval, silicone lubricant, vehicle fluids, vehicle maintenance, and white lithium grease. Entry-level technicians cut their teeth on vehicle maintenance tasks such as performing fluid service, checking tires, and making light mechanical repairs. Therefore, this chapter is extremely important if you are planning a career in the automobile repair industry. It is your chance to learn basic service tasks essential to what may be your first job in an auto shop. Study this material carefully. The last section of the chapter discusses recycling. To help save our environment, recycle as many automotive parts, fluids, and materials as possible. Used batteries, tires, antifreeze, and oils can all be recycled into new products while saving energy and reducing air and water pollution. Vehicle maintenance. Vehicle maintenance. Vehicle maintenance includes any operation that will help keep a vehicle in good operating condition. Proper maintenance is vital to keep a vehicle in good working order. A technician must be familiar with all aspects of vehicle maintenance, including checking fluid levels and condition, changing engine oil and the oil filter, changing automatic transmission fluid, lubricating chassis parts that have grease fittings, checking tires for wear and proper inflation, locating fluid leaks and other obvious problems, following state regulations for recycling and disposal of waste fluids. Without proper maintenance, the life of an automobile may be reduced by thousands of miles. For example, fluids can become contaminated and change chemically after prolonged use. This can cause premature wear, corrosion, and mechanical failure of parts. Tech tip. You may be familiar with the old adage, you can pay now or you can pay later. In the automotive field, this means that your customers can pay a little for maintenance today or pay a whole lot more for repairs later. A poorly serviced vehicle will wear out and break down much sooner than a well-maintained vehicle. In the long run, vehicle maintenance saves your customers money. Fluid service. Vehicle fluids include engine oil, coolant, brake fluid, transmission fluid, power steering fluid, and other liquids. When working as a technician, you must be able to safely and efficiently check and, when necessary, change vehicle fluids without contaminating them. Service information or the owner's manual for a given vehicle will contain detailed information on how to check and change all vehicle fluids. This includes the location of all fluid checkpoints, drain points, and fill points. The correct interval, or timer mileage, between fluid checks and changes, and the correct types and quantities of fluids to be used. This information varies by year, make, and model of vehicle. For example, a diesel supercharged or turbocharged engine often requires more frequent oil changes than naturally aspirated spark ignition engines. Transmission and transaxle fluids, differential lubricants, brake fluids, and other fluids can also vary slightly in chemical content to match the internal design of the assembly. Tech tip. A vehicle's warranty may become void if incompatible fluids, incorrect service procedures, or improper intervals are used. For this reason, refer to the manufacturer's recommendations and specifications when servicing fluids. Buzzword. Fluid capacity is the recommended amount of fluid a system or assembly should hold. The vehicle manufacturer will list fluid capacities for the engine, transmission, differential, power steering system, and other systems and assemblies. Procedure checking engine oil. Service procedure to check engine oil. Warm the engine to operating temperature. Shut off the engine and allow it to sit for a few minutes. Locate and remove the engine oil dipstick. Wipe off the dipstick and reinsert it all the way into its tube. Pull the dipstick back out and hold it over your shop rag. Observe the highest point on the dipstick that is wet from oil. The oil level should be between the add low and full marks on dipstick. Before reinstalling the dipstick, inspect the condition of the oil. The oil should not smell like gasoline or be too dirty. If the oil level is low, add the correct amount and type of oil. If the oil level is down to the add mark, 1 quart is typically needed to bring it up to the proper level. If the dipstick reads halfway between add and full, you will need to add only 1/2 quart. Never add too much oil to an engine. Pour in only enough oil to reach the full mark on the dipstick. Overfilling can lead to oil foaming, air bubbles resulting from agitation of the oil by the crankshaft, which reduces the oil's lubricating ability. Warning! Be careful when checking or changing vehicle fluids. At operating temperature, oil and other fluids may be hot enough to burn your skin. Wear a face shield and oil-resistant gloves when changing an engine's oil and filter. Adding engine oil. When adding engine oil, be sure to use the type and weight recommended by the manufacturer. Unless you have an engine with extremely high mileage, use the same weight of oil that was installed during the last oil change. You can use heavier or thicker oil in engines with very high mileage, especially if the engine is knocking, smoking, or has low oil pressure. Thicker oil will help raise oil pressure, cushion excessive bearing clearance, reduce light knocking, and help lower engine blow-by and smoking slightly. For example, some engines require zero weight oil when new. When these engines reach 100,000 miles or more, they may benefit from heavier oil, 20W-40, for example. The heavier oil will cushion worn parts and make the engine run quieter. However, fuel consumption may increase slightly with heavier oil. To add oil to the engine, remove the oil cap, which is usually on the valve cover. Install a clean funnel into the filler opening without spilling. Pour the oil slowly into the funnel and engine. Changing engine oil and filter. Check the manufacturer's recommendations on oil change intervals. Generally, engine oil should be changed every 5,000 to 12,000 miles, or 8,000 to 9,000 kilometers. When changing engine oil, make sure the engine is warm and the vehicle is sitting level. This will ensure that more of the oil contaminants are suspended in the oil and will be removed when the oil is drained from the engine. If the oil is cold, the oil will drain more slowly and debris will settle to the bottom of the oil pan and cylinder heads. Service procedure to change the engine oil. Warm the engine to operating temperature. Put on eye or face protection and work gloves. Raise the vehicle on a lift or place it on jack stands in a level position. Place a catch pan under the oil drain plug. Unscrew the drain plug by turning it counterclockwise. Be careful, as the oil is hot. Allow enough time for the oil to drain completely and stop dripping out of the pan. Carefully reinstall the drain plug to prevent cross-threading. The threads in the pan and on the drain plug can strip easily. Torque the drain plug to minimum torque specifications. Apply only enough torque to draw the drain plug snug on its seal and prevent leakage. Position your catch pan under the oil filter. Using an oil filter wrench, as shown in figure 9-4, unscrew the filter. Be careful so that hot oil does not run down your arm and burn you. Obtain the correct replacement oil filter. Compare the old and new filters. The threads and O-ring seals must be the same size. Wipe some clean oil on the rubber O-ring seal as shown in figure 9-5 and thread the new oil filter into the engine. Tighten the oil filter by hand. Placing a clean shop rag over the filter before tightening will help you get a proper grip. Never use an oil filter wrench to tighten an oil filter, or you will have to cut the filter off the next time. Over-tightening may also distort the O-ring and cause a severe oil leak. Lower the vehicle to the ground and add the correct amount and type of oil. Start the engine and make sure the oil pressure light goes out or oil gauge reads normally. Let the engine run while checking for leaks under the engine compartment. Shut off the engine and check the oil level again. Automatic transmission or transaxle fluid and filter service. Like engine oil, automatic transmission and transaxle fluid should be checked and changed at specified intervals. The fluid can become contaminated with metal, dirt, moisture, and friction material or non-metallic, heat-resistant, fibrous substance from internal parts. This can cause rapid part wear and premature transmission or transaxle failure. To check the fluid in an automatic transmission or transaxle, warm up the engine and move the gear selector through all positions. Apply the parking brake, shift the transmission into park, and block the wheels. With the engine still running, locate the transmission dipstick. Tech tip. The transmissions and transaxles on some late model cars and light trucks are sealed at the factory and do not have dipsticks. They do not require fluid changes, periodic fluid level checks. Some manufacturers provide screw plugs on the side of the transmission or transaxle case that are to be used for checking and adding transmission fluid. The procedure is similar to that for checking and adding fluid in a manual transmission. Now, pull out the dipstick, wipe it off, and reinsert it into the tube. Remove the dipstick again and hold it over a shop rag. The fluid level should read about between the add and full marks on the dipstick. Also, inspect the fluid for discoloration and odor. If it smells burned or looks dirty, the fluid should be changed. It is very easy to overfill an automatic transmission. Seldom do you have to add a full quart. Normally, if the dipstick reads add, only a fraction of a quart is needed to fill the transmission. Sometimes instructions are written on the dipstick. If in doubt, check your service information or owner's manual. Service procedure. To change the fluid and filter in an automatic transmission or transaxle, warm the engine and transmission or transaxle to full operating temperature so the fluid will pick up debris and drain more fully. Raise the vehicle on a lift or secure it on jack stands. If the transmission pan has a drain plug, remove the plug and allow the old fluid to drain into your catch pan. If the pan does not have a drain plug, remove the pan as outlined in steps 3 to 10. Remove all but one of the bolts securing the transmission pan. Be careful not to spill the hot transmission fluid. It can cause painful burns. Loosen but do not remove the last pan bolt while holding the pan in place with a shop rag. Allow the pan to drop and let the fluid pour into the catch pan. Unscrew the last pan bolt and remove the pan. If needed, replace or clean the transmission filter. Clean the oil pan, flange, and its mating surface on the transmission housing. To prevent leaks, these surfaces must be clean and dry. Position the new pan gasket using an approved sealer. If a rubber seal is used, fit it into its groove in the pan or housing. Use the sealer sparingly. You do not want it to squeeze out into the transmission or transaxle housing. Start all the pan bolts with your fingers. Tighten the pan bolts into a crisscross pattern to their recommended torque specification. Over-tightening can split the gasket or distort the flange on the pan. Refill the automatic transmission or transaxle with the correct type and amount of transmission fluid. Follow the manufacturer's instructions for refilling the unit. After checking fluid level on the transmission dipstick, start the engine and shift through the gears. Look under the car for signs of leaks and recheck the fluid level before releasing the car to the customer. Tech tip. If a transmission or transaxle has more than 100,000 miles on it without a previous fluid change, the worst thing you can do is change the fluid. The old transmission fluid is full of friction material that prevents clutch slippage. If you install fresh transmission fluid in a high mileage, badly worn automatic transmission, the transmission will most likely slip and eventually fail. You or the shop could be liable since the transmission worked fine before the fluid change. Manual transmission fluid service. To check the fluid in a manual transmission, locate and remove the transmission fill plug. It is normally on one side of the transmission. Generally, warm fluid in a recently driven vehicle should be even with the fill hole. When the transmission fluid is cold, the fluid can be slightly below the fill hole. Some manufacturers suggest that manual transmission fluid be changed periodically. Others do not. If a fluid change is needed, remove the drain plug on the bottom of the transmission case and allow all the fluid to pour into your catch pan. Replace the drain plug and install the right type and quantity of fluid. Lubricate the gear shift mechanism and clutch release as described in the service information. Differential fluid service. To measure the fluid level in a differential or rear axle assembly, remove the fill plug. It will normally be on the front, back, or side of the differential. When the lubricant is hot, it should be even with the fill hole. When the fluid is cold, it should be slightly below the fill hole. At the manufacturer's recommended change interval, remove the drain plug. It will be on the bottom of the differential. After all the fluid has drained from the differential, reinstall the drain plug and fill the unit with the proper lubricant. If a drain plug is not provided, a special siphon or suction gun can be used to draw the fluid from the differential. Caution! Positive traction or limited slip differentials or both wheels turn for added traction often require special lubricant. Refer to the vehicle identification number and the appropriate service information for details. If you install the wrong lubricant, differential action and traction can be adversely affected. Checking engine coolant. Engine coolant, mixture of water and antifreeze, is used inside an engine's cooling system. Engine coolant must be changed periodically. After prolonged use, engine coolant will deteriorate and become acidic and very corrosive. The resulting corrosion inside the engine and radiator will fill the old coolant with rust. Old acidic coolant will result in premature water pump, thermostat, and radiator failure. To check the coolant level, look at the side of the plastic overflow tank connected to the radiator. The coolant should be between the hot and cold marks on the side of the tank. Warning: never remove a radiator cap while the engine or radiator is hot. Extremely hot coolant can spray out of the radiator, causing serious burns. If the system is cool to the touch, it is safe to remove the radiator cap. Turn the cap counterclockwise about half a turn and pull up. The coolant should be about 1 inch or 25 millimeters down in the radiator when cool. Inspect the condition of the coolant by dipping a white paper towel into the radiator. If rusty, the coolant should be drained and replaced. Checking power steering fluid. Power steering fluid level should be checked regularly. The engine must be shut off when checking power steering fluid. If the fluid is contained in a clear plastic reservoir, simply compare the fluid level to the markings on the side of the reservoir. In some vehicles, the level is checked by removing a dipstick from the power steering pump. Inspect the fluid level on the dipstick closely. If the fluid is low, check for and correct any leaks. Then add the correct type and amount of power steering fluid. Burned power steering fluid has been overheated from pump wear or a clogged line or passage in the hydraulic system. It will smell like burned rubber. The burned fluid must be flushed and replaced. Tech tip. A common and troublesome mistake is accidentally overfilling the power steering system. If you add too much power steering fluid, the extra fluid will spray out all over the engine compartment. Remember that liquids cannot be compressed. If you overfill the reservoir, use a clean squeeze bulb to suck out the extra fluid. Checking brake fluid. Brake fluid levels should be checked at least twice a year. The master cylinder is normally mounted on the firewall, or body section between the engine and the passenger compartment. When the master cylinder reservoir is clear plastic, simply compare the fluid level to the markings on the reservoir. The fluid should be between the add and full marks. With some master cylinders, you must remove the reservoir cover to check the fluid. Generally, the fluid should be about 1/4 of an inch or 6 millimeters down from the top of the reservoir. Add the recommended type of brake fluid as needed. Most auto manufacturers recommend the periodic replacement of brake fluid. Changing brake fluid removes rust particles, water, and other contaminants from the system. Refer to factory procedures to flush the brake system and install new brake fluid. Caution: never let anything, oil, grease, dirt, contaminate the brake fluid. Oil and grease, for example, can attack the rubber parts in the brake system, which can lead to the loss of braking ability and the need for major repairs. Also, note that the brake fluid will dissolve paint. Clean fluid spills from fenders in the engine compartment right away, or you may have to pay for a fresh paint job. Checking hydraulic clutch fluid. Many manual transmission clutches use a hydraulic system rather than a mechanical linkage rods or cables to disengage the clutch. A clutch master cylinder produces hydraulic pressure to activate a clutch release mechanism. The fluid in the clutch master cylinder should be checked. If the fluid level is low, add the recommended type of hydraulic fluid to fill the reservoir to the full mark. Always look for leaks when checking a hydraulic clutch system. Checking manual steering fluid. Manual steering fluid is checked by removing either a fill plug or a designated bolt from the top of the steering box or rack. The lubricant should be almost even with the plug or bolt opening. If not, add the recommended fluid to the specified level. Checking windshield washer solution. The windshield washer solution is normally visible through the side of the plastic storage tank in the engine compartment. If the washer solution is low, add solution to the tank until it is full. The solution will aid windshield cleaning and prevent ice formation in cold weather. Never use plain water in place of windshield washer solution. The water will freeze and expand in cold weather, and it may crack the reservoir tank. Checking battery. New cars use maintenance-free batteries, which do not require an electrolyte or acid check. However, make sure that the battery terminals and case top are clean. A battery post and cable cleaning tool can be used on corroded connections. If the top of the battery is dirty, it can be cleaned with a solution of baking soda and water. Filter service. Quite often, various filters used in a vehicle are replaced during lubrication service. In addition to the engine oil and transmission filters, the technician may need to change air and fuel filters. If an air filter is dirty, it is normally replaced. However, some manufacturers permit light dirt and dust to be tapped from the filter. Cabin filters are air filters that clean the air flowing into the passenger compartment. They are often high-density filters that block pollen and other airborne particles. Cabin filters are usually located and accessed under the right side of the dash. Fuel filters can be located almost anywhere in the fuel system. Modern fuel systems often use an inline fuel filter between the fuel tank and the engine. Most fuel systems also have a fuel strainer on the pickup tube in the fuel tank. Refer to the factory service information for exact filter locations and change intervals. Warning: wear a full face shield and wear gloves when servicing fuel lines. Hold a shop rag around fuel line fittings when loosening them. The shop rag will keep fuel from spraying out due to residual pressure in the line, preventing a possible explosion and fire. Place any gasoline-soaked rag in a metal safety can with a metal lid right away. Do not keep using it, as it is extremely flammable. Chassis lubrication. Chassis lubrication generally involves greasing high friction points on the suspension and driveline of the vehicle. It may also involve lubricating locks, hinges, latches, and other body parts. Grease job. In the past, a grease job was an integral part of chassis lubrication. A grease job involves lubricating high friction pivot points on the suspension, steering, and drivetrain systems. During a grease job, a grease gun is used to force heavy grease into small grease fittings on ball joints and some universal joints on the drive shaft. Late model vehicles with original equipment parts do not have grease fittings and, therefore, do not require periodic grease jobs. However, some aftermarket ball joints and universal joints have grease fittings and should be lubricated periodically. Inject only enough grease to fill the cavity in the part. Over-greasing can sometimes rupture the rubber boot surrounding the joint. Tech tip: when doing any kind of lubrication service, protect the customer's vehicle from oil and grease damage. Use seat covers, paper floor mats, and fender covers to protect surfaces from oil and grease stains. A stained carpet or seat cover can be very expensive to replace. Body lubrication. High friction points on a vehicle's body, or hinges and latches on doors, hoods, and trunk, should be lubricated periodically. This will help prevent squeaking doors, ticking hinges, and wear problems. Always use the recommended lubricant. Normally, rubber and plastic parts will deteriorate if exposed to petroleum-based lubricants, or oils and grease. Silicone lubricant should be used on plastic and rubber components. The most common types of body lubricants are silicone lubricant. Silicone lubricant often comes in a spray can. It is well suited for rubber door weather stripping and windows. It is a dry lubricant that will not soil windows and clothing. Graphite. Graphite is excellent for door and trunk locks. It will not collect dust and dirt, which could upset lock operation. Dry stick or wax lubricant. Dry stick lubricant is desirable on door latches and strikers, or post that engages door latch. It will not stain clothing. Engine oil. Engine oil is used on hard-to-reach, high-friction points. White lithium grease. White lithium grease is good all-around body lubricant. It can be used on door hinges, hood latches, and trunk latches. Checking tires. Service procedure. To check a vehicle's tires for safety. Inspect the condition of the tire threads. Generally, tire thread depth, or depth of grooves in the tires, should be at least 1/8 of an inch, or 3.2 millimeters deep. If tread depth is less than this, inform the shop supervisor or vehicle owner. New tires are recommended to improve traction and prevent a dangerous tire failure. If tire tread depth is acceptable, measure the tire inflation pressure. Remove the valve stem cap and press the tire pressure gauges chuck squarely over the valve stem. Read the gauge and compare the pressure reading with the vehicle manufacturer's pressure recommendations. Note that the vehicle manufacturer's inflation pressure recommendations are printed on a sticker that is typically located on the driver's door jamb, on the edge of the driver's door, or in an inward-facing surface adjacent to the driver's seat. The pressure listed on the tire's sidewall is maximum inflation pressure, not the manufacturer's recommended inflation pressure. If the tire inflation pressure is low, add air to the tire until the recommended pressure is reached. If the pressure is high, press on the valve core pin in the stem to release air from the tire as needed. Recheck inflation pressure with your gauge until it is correct. Reinstall the valve stem cap. Repeat steps 1 to 4 on the other 3 tires. Service intervals. A service interval is the amount of time in months or the number of miles between recommended service checks or maintenance operations. Your shop service software will give it exact intervals for the particular make, model, and year of vehicle you are servicing. Note some typical service intervals in Figure 9-18. General inspection and problem location. As you perform lubrication service or any kind of auto repair, always look for potential problems. Visually inspect the engine compartment for signs of wear and deterioration, as well as loose parts and air and fluid leaks. Check the condition of fan belts, water hoses, fuel hoses, vacuum hoses, air intake ducts, and wiring harness. This can be done as you are working. Hose inspection. Hose. Yeah, but the hose. Check all hoses for hardening, softening, cracking, splitting, and other signs of impending failure. Squeeze all the hoses. Squeeze. If the hoses are deteriorating, hard or soft, inform the customer or shop supervisor of the problem. Drive belt inspection. Check the drive belts for cracks, splits, tears, cuts, and wear. If belts are worn or wear hardened and cracked, they may slip and squeal. Wiring inspection. Check wires for improper routing, cracked or brittle insulation, or other obvious problem signs. Make sure wires are away from all moving or hot parts. Tire inspection. Check tires for excessive wear, improper inflation pressure, and physical damage. Tire maintenance is very important from a safety standpoint. Badly worn tires can blow out, causing a loss of vehicle control and resulting in a collision, injuries, or even death. Steering system inspection. Check steering system components for excessive wear and for play between moving parts. The steering wheel should not move more than about 1 inch or 25 millimeters without causing front wheel movement. If it does, wear in the steering mechanism is indicated. Exhaust system inspection. Check the exhaust system for damaged, rusted, or leaking parts. Exhaust system components should be inspected any time a vehicle is raised on a lift. A leaking exhaust system can be very dangerous, as it may allow poisonous exhaust gases to enter the vehicle's passenger compartment. Look for rust holes in the pipes, muffler, and other parts. Brake inspection. Brake inspection involves removing a vehicle's wheels so you can visually examine the brake pads and rotors. If brake parts are damaged or worn, inform the customer of the need for brake repairs. Fluid leaks. Fluid leaks result from bad gasket seals or hoses, cracks in parts, and similar troubles. Leaks are very common problems that should be corrected immediately. To become good at leak detection and correction, you should be familiar with the color, odor, and feel or texture of the different fluids. This will allow you to quickly identify the source of any fluid leak. Does the fluid feel more like water or oil? Dabbing a white paper towel into a puddle of fluid will allow you to see the fluid's color more accurately. Oil will be slippery to the touch and will be dark brown or almost black if used for an extended period. If the fluid is clear or brown and feels squeaky and when rubbed between your fingers, it is probably brake fluid or hydraulic clutch fluid. Antifreeze can be green, orange, pink, or rust-colored and will feel slick. Automatic transmission fluid can be dark brown, red, or dark green. Power steering fluid can be amber, red, or clear and will feel like transmission fluid. Each fluid has a distinct odor. Memorize how each fluid smells. Fluid leaks tend to flow downward and to the rear of the vehicle. For this reason, look for leaks above and slightly in front of where you find fluid dripping off the vehicle. If the leaking part is badly soiled, clean the area thoroughly. This will make it easier to see fresh fluid leaking out of the assembly. Tech tip. The most frequent cause of fluid leakage is broken gaskets and worn seals. Replacement will usually correct the problem. Noise detection and location. Abnormal noises often indicate part wear or other mechanical problems. They are common to almost all systems of a vehicle. When test driving a vehicle or idling the engine in the shop, listen for unusual sounds, knocks, clunks, rattles, clicks, squeaks, and hisses. Locating the source of these sounds will help you identify problems that might not set a trouble code. A stethoscope, similar to that used by a doctor to listen to a patient's heart, is commonly used by an auto technician. It will help the technician pinpoint the source of internal part noises. To use the stethoscope, touch the probe on the assembly near the abnormal sound. Move the stethoscope around until the sound is the loudest and you have found the problem source. Recycling and disposal of auto shop wastes. Recycling and the proper disposal of auto shop waste helps save our planet's natural resources and reduce pollution. Laws have been passed that require specific procedures when handling and discarding potentially harmful materials. Auto shop wastes. Automotive maintenance and repair generates hazardous waste that come under the requirements of the Resource Conservation and Recovery Act. This federal act covers businesses that generate, transport, and manage hazardous wastes. Any business that maintains or repairs vehicles, heavy equipment, or farm equipment is classified as a vehicle maintenance facility by this act. Fluid and solid waste commonly generated during vehicle maintenance include used engine oil, can be combustible and may contain toxic chemicals. Other discarded lubricants such as transmission and differential fluids may contain toxic chemicals. Used cleaners and degreasers contaminated from parts cleaning operations. Fuel injection system cleaners, flammable and may contain toxic chemicals. Rust removers, may contain strong acidic or alkaline solutions. Paint thinners or reducers, may be ignitable or contain toxic additives. Worn out 12 volt or HV batteries contain lead and sulfuric acid. Failed hybrid batteries contain flammable lithium. Certain used parts such as brake pads or shoes, old tires, and catalytic converters. Recycling engine oil. Used engine oil is considered hazardous waste only if it is not destined to be recycled. The used oil should be stored in an improved container for recycling. Always send used engine oil to a recycling center. Most recycling companies provide a pickup service for the used oil. Recycling coolants. Antifreeze is classified as a hazardous waste due to the heavy metals and chlorinated solvents it picks up while circulating through the cooling system. Regulations require that spent antifreeze solutions be collected by a registered hazardous waste hauler or recycler. Local companies usually offer pickup and recycling services. Recycling refrigerants. Refrigerants, such as R134A, removed from automotive air conditioning systems during servicing, should not be vented to the atmosphere. State regulations require that refrigerants be recovered and recycled. As you will learn in later chapters, systems are now available for recovering, cleaning, and recycling air conditioning refrigerants. Other automotive recyclables. Other recyclable materials that are commonly removed from service during maintenance and repair of vehicles include catalytic converters, which contain platinum, worn tires, which can be sold to a retread company if the carcass is sound, or to a shredder. Shredded rubber is an ingredient in road resurfacing materials and other products. Batteries can be recycled and used to make new batteries. This prevents lead, acid, and other materials from adding to our waste disposal problems. A local battery recycler will normally pick up used batteries. Brake shoes and pads can be recycled and sold as cores for making reconditioned brake components. Many small assemblies, alternators, starters, master cylinders, etc., can be recycled and made into rebuilt assemblies. Summary. Vehicle maintenance includes any operation that will help keep a vehicle in good operating condition. Vehicle fluids include engine oil, coolant, brake fluid, transmission fluid, power steering fluid, etc. A car's warranty can become void if incompatible fluids, incorrect service procedures, or improper intervals are used. Oil and other fluids at operating temperature can be hot enough to burn your skin. Never remove a radiator cap while the engine or radiator is hot. Boiling coolant can spray out of the radiator, causing serious burns. Hold a shop rag around fuel line fittings when loosening them. This will keep fuel from spraying or leaking out, preventing a possible explosion and fire. As you perform any kind of auto service, always look for obvious problems. EPA, Environmental Protection Agency, guidelines and state regulations affect how you must handle and dispose of used fluids, solvents, batteries, and other shop waste materials. A stethoscope, similar to that used by a doctor to listen to a patient's heart, is commonly used by a technician to find abnormal noises. This concludes the Modern Automotive Technology Chapter 9 audio book. Vehicle maintenance, fluid service, and recycling. My name is Joseph Cuevas. You will be hearing more chapters from me, and I hope to get better in my pronunciation and flow of words. Stay tuned. I hope this is useful to you.